This is a big year for NASA's MAVEN orbiter. What it could learn could someday help future astronauts safely land on Mars and provide us with a new view of the sun.
Hi everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. But I came across this over at NASA. This should be entertaining. NASA watches Mars light up during epic solar storm. Wow. Yes, the specks in this scene were caused by charged particles from a solar storm. These are in the top left-hand side there that we can see up in the sky. Hitting a camera aboard NASA's Curiosity Mars rover. Curiosity used its navigation cameras to try and capture images of dust devils and wind gusts like the ones seen here. What else do they have there? Yeah. NASA's Curiosity Mars rover captured black and white streaks and specks using one of its navigation cameras just as particles from a solar storm arrived on the Martian surface. These visual effects are caused by energetic particles hitting the camera's image detector. Very interesting indeed. Absolutely fascinating. Love it. Now, in addition to producing auroras, a recent extreme storm provided more detail on how much radiation future astronauts could encounter on the red planet. Now, Mars scientists have been anticipating epic solar storms ever since the Sun entered a period of peak activity earlier this year called solar maximum. Over the past month, NASA's Mars rover and orbiters have provided research with front row seats to a series of solar flares and coronal mass ejections that have reached Mars, in some cases even causing Martian auroras. And as usual, I'll leave the link to the main article below the video so you can pop in, check out these embedded links, go for a bit of a deeper dive if you want beyond the main article. Makes for an interesting read, believe me. Now, this science bonanza has offered an unprecedented opportunity to study how such events unfold in deep space, as well as how much radiation exposure the first astronauts on Mars could encounter. Now, the biggest event occurred on May 20 with a solar flare later estimated to be an X12. X-class solar flares are the strongest of several types, based on data from the Solar Orbiter spacecraft, a joint mission between the ESA, the European Space Agency, and NASA. Now, the flares sent out X-rays and gamma rays towards the red planet, while a subsequent coronal mass ejection launched charged particles. Moving at the speed of light, the X-rays and gamma rays from the flare arrived first, while the charged particles trailed slightly behind, reaching Mars in just tens of minutes. Wow, that's pretty quick. Again, I'm not a scientist, not an astronomer or astrophysicist or planetary person, but so I don't even know what it's called. But if there is anybody out there who's watching this video, please, who's an expert in this area, please feel free to comment on it. Love to hear from them. I just love sharing science stories with everybody. I just love science. I'm a bit of the old science nerd. It gets me all excited down in my nerdy nether regions. But then again, my personal life is no concern of yours, yes. The unfolding space weather was closely tracked by analysts at the Moon to Mars Space Weather and Analysis Office at NASA's Goddard Space Flight Center in Greenbelt, Maryland, which flagged the possibility of incoming charged particles following the coronal mass ejection. Now, if astronauts had been standing next to NASA's Curiosity Mars rover at the time, they would have received a radiation dose of about 8,100 micrograys, equivalent to 30 chest X-rays. Now, while not deadly, it was the biggest surge measured by Curiosity's Radiation Assessment Detector, or RAD, since the rover landed 12 years ago. Yeah. Now, while that wouldn't be deadly, it wouldn't be something that you'd want on a regular basis 24/7, I'm assuming. It would not be very good for you. Yeah. Well, here's a little video here that's it's the purple color in this video shows auroras on Mars' night side as detected by the ultraviolet instrument aboard NASA's MAVEN orbiter between May 14 and 20, 2024. The brighter the purple, the more auroras that were present. Very, very interesting. Well, there's a little video here that I think we should check out. And let's have a quick look at it. And then we'll carry on the conversation when we come out the other side. Well, that was really interesting. I love that, little clips like that, sort of showing all this data that's gathered and put together into image form. That's fascinating. Now, RAD's data will help scientists plan for the highest level radiation exposure that might be encountered by astronauts who could use, I guess, shelter on the Martian landscape for protection. I did a video which I'll link down below here. It's terrible, by the way, NASA. You better get your grammar bloody checker up and running. All the money they spend, you think they could afford one. A little video I did with some holes encountered on Mars, and it's believed that they are collapsed lava tubes from when Mars was volcanically active, and perhaps the astronauts could use those. And then, of course, from that, when the moon, we start going back to the moon with our Artemis missions, the moon was volcanically active so many millions or billions of years ago. Again, I'm not an astronomer or planetary scientist. I don't know how long it was ago, but the principle could be the same. We could use those for a temporary shelter until we build shelters on the surface. Same with Mars and its collapsed lava tubes. Interesting. Oh, here we go. Cliff sides or lava tubes would provide additional shielding for an astronaut from such an event. Link below this video. In Mars orbit or deep space, the dose rate would be significantly more, said RAD's principal investigator, Don Hassler of Southwest Research Institute Solar System Science and Exploration Division in Boulder, Colorado. I wouldn't be surprised if this active region on the sun continues to erupt, meaning even more solar storms at both Earth and Mars over the coming weeks. Now, during the May 20 event, so much energy from the storm struck the surface that black and white images from Curiosity's navigation cameras danced with snow, white streaks and specks caused by charged particles hitting the camera. Now, similarly, the STAR camera at NASA's 2001 Mars Odyssey orbiter used for orientation was inundated with energy from solar particles momentarily going out. Odyssey has other ways to orient itself and recovered the camera within an hour. Even with the brief lapse in its STAR camera, the orbiter collected vital data on X-rays, gamma rays, and charged particles using its high-energy neutron detector. Now, this wasn't Odyssey's first brush with a solar flare. In 2003, solar particles from a solar flare that was ultimately estimated to be an X-45 fried Odyssey's radiation detector, which was designed to measure such events. Interesting. And here's a little video we've got here. We can learn how NASA's MAVEN and the agency's Curiosity rover will study solar flares and radiation at Mars during solar maximum, a period when the sun is at its peak activity. Yep, let's have a look at this little video and we'll carry on the conversation when we come out the other side as usual.
This is a big year for NASA's MAVEN orbiter. What it could learn could someday help future astronauts safely land on Mars and provide us with a new view of the sun. This is mission control at NASA's Jet Propulsion Laboratory. This is where all of the data from MAVEN comes through. 10 years ago, we sent MAVEN to Mars to measure space weather and how it interacts with the upper atmosphere. This includes solar flares, which are giant explosions on the sun, which send radiation into space. Every 11 years, the sun goes through cycles of activity. This year, we've seen more space weather than we ever have during the entire mission. And while solar flares can occur at any time, they occur more frequently and more intensely at the peak of this cycle called solar maximum. Right now, we're almost at that peak, and I'm really excited about what solar flares can teach us about the red planet. MAVEN is one of 2 missions studying radiation at Mars. The orbiter is able to observe many phenomena from the sun, including radiation, high-energy particles, and magnetic fields. MAVEN can also see stunning auroras from its vantage point high above the planet, which future astronauts might be able to see someday. Meanwhile, down on the surface of Mars, the Curiosity rover has a radiation detector called RAD. It studies high-energy particles that get all the way through the atmosphere and down to the surface. Together, MAVEN and Curiosity give us a better understanding of the radiation environment at Mars. Studying how intense solar flares can get during solar maximum can help NASA develop protection for future astronauts, robots, and spacecraft. There's another advantage to studying the sun from Mars. Here on Earth, we can only see one side of the sun. But when MAVEN is on the other side, it can spot activity coming days before we can. On a personal note, MAVEN is my spacecraft baby, and I am so excited about observing the next few years of solar flares, space weather, and the atmosphere of Mars.
Well, that was intensely interesting. I find that really incredible. I love this sort of stuff. This is awesome. Auroras over Mars. High above Curiosity, NASA's MAVEN, Mars Atmosphere and Volatile Evolution Orbiter, captured another effect of the recent solar activity, glowing auroras over the planet. The way these auroras occur is different than those seen on Earth. Now, our home planet is shielded from charged particles by a robust magnetic field, which normally limits auroras to regions near the poles. Solar maximum is the reason behind the recent auroras seen as far south as Alabama. Now, Mars lost its internally generated magnetic field in the ancient past, so there's no protection from the barrage of energetic particles. When charged particles hit the Martian atmosphere, it results in auroras that engulf the entire planet. Okay. It's interesting. It's something I was not aware of, that Mars didn't have a magnetic field. Interesting. So during solar events, the sun releases a wide range of energetic particles. Only the most energetic can reach the surface to be measured by RAD. Slightly less energetic particles, those that cause auroras, are sensed by MAVEN's Solar Energetic Particle Instrument. It's interesting. Scientists can use that instrument's data to rebuild a timeline of each minute as the solar particles screen past, meticulously teasing apart how the event evolved. God, you got to have some patience to be an astronomer. I don't think I could do that. This was the largest solar energetic particle event that MAVEN has ever seen, said the MAVEN Space Weather Lead, Christina Lee, at the University of California, Berkeley's Space Sciences Laboratory. There have been several solar events in the past weeks, so we were seeing wave after wave of particles hitting Mars. New spacecraft to Mars. This should be interesting. The data coming in from NASA's spacecraft won't only help future planetary missions to the Red Planet. It's contributing to a wealth of information being gathered by the agency's other heliophysics missions, including Voyager, Parker Solar Probe, and the forthcoming Escape and Plasma Acceleration and Dynamics Explorers mission. Wow, can't wait for that. That should be really cool. Now, targeting a late 2024 launch, Escapade's twin small satellites will orbit Mars and observe space weather from a unique dual perspective that is more detailed than what MAVEN can currently measure alone. A little more about the missions. Curiosity was built by NASA's Jet Propulsion Laboratory, which is managed by Caltech in Pasadena, California. JPL leads the mission on behalf of NASA's Science Mission Directorate in Washington. Now, MAVEN's principal investigator is based at the Laboratory for Atmospheric and Space Physics, or LASP, in the University of Colorado Boulder. LASP is also responsible for managing science operations and public outreach communications. NASA's Goddard Space Flight Center in Greenbelt, Maryland, another legend that was named after Robert Goddard. Talk about a bloody rocket, man. That guy was incredible. Manages the MAVEN mission. Now, Lockheed Martin Space built the spacecraft and is responsible for mission operations. NASA's Jet Propulsion Laboratory in Southern California provides navigation and deep space network support. The MAVEN team is preparing to celebrate the spacecraft's 10th year at Mars in September of 2024. That's cool. That's really cool. I remember going back to the old days, and I wish we had engineers like that could make cars, as long as you maintain them, that would last 10 or 20 years. Now, if you maintain them, you get rid of them after 2 years. They start falling apart or something. It's quite fascinating. You know, as I said, these spacecraft, and look at the Voyager probes, nearly 50 years in space. They're having a few things break down on them, but come on, 50 years, and they haven't been into the shop once for a service? That's unbelievable. I love it. Yep, and as usual, leave the links to the main article below the video so you can pop in and check out these embedded links. Makes for a fascinating read, believe me. Absolutely incredible. Love this stuff. As I say, love all science, especially the planetary science and some of the images we're getting back from these missions. And I just can't wait for our missions to, the moons of Saturn and Jupiter. And hopefully we'll be able to find some life in those oceans under those, under the surface. It'd be absolutely incredible. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. Greatly appreciate it. If you're up for it, drop a comment down below the video. I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
please, Spock, do me a favor. And don't say it's fascinating. No. But it is interesting.